All right, so back at this problem, we're going to get a solution to this thing. If you're just watching this video for the first time, you might want to press pause and give this a shot, and then press play to see if your answer matches up with ours. But we're here live today and going through this problem. First thing I need to do is make some room and create a diagram to help me organize the information. So I created a diagram that showed that the camera was over on the left. The launch pad for the rocket was 4,000 feet away. The rocket is going to go up in the air. They told us that the rate of the rocket is 600 feet per second at the instant that it's 3,000 feet in the air. I'm letting R represent the height of the rocket. You might have chosen Y because it's a vertical distance. You might have chosen H because it's a height. Or you might even just chosen X because you like it. And then the question is going to ask me about the distance between the camera and the rocket. So I represented that distance with a dashed line and labeled that C. No real reason to pick C except that it's the hypotenuse of a right triangle, and when you first learn the Pythagorean theorem, you label that side C. So that's why I put it there. It just helps me remember where that comes from. At this point, I'm ready to determine what's given and what I'm asked. There's really only one given rate, and that is in terms of R, dr dt, right? dr dt is given as 600 feet per second. And then since there's an A and a B part, there's two unknowns. What's the first unknown they're asking us in terms of the variables I have here? Yeah, dc dt. When what? So when R is 3,000? Okay, and the second question they're asking me in B is d theta dt. How fast is that angle increasing? And again, that's at the same moment. So that's when R is 3,000 feet. So that's my initial diagram and my given and unknown, so I can try to answer a question here. Questions so far? You guys all worked on this yesterday and maybe a bit last night too. Where'd you go from here? Right away you just found out what C at the instant R was 3,000? Okay, that'll come up on this slide. It's a nice 3-4-5 ratio, so that made that pretty straightforward. What else? What else do you need? Yeah, what equation or function did you work on here? Pythagorean? Sure. So I think in terms of these variables and labels, we're going to have C squared equals 4,000 squared plus R squared. Notice I didn't take the time to figure out 4,000 squared, even though it's not that hard. It just makes it a longer number to write, because what's going to happen to that here pretty quick? It's going to zero out anyway. It's just a constant, so it doesn't matter how big it is or what format I write it in, it's going to zero out. I need to get down to a dc dt and a dr dt, so at this point I just went ahead and took the derivative of both sides. So the left side becomes 2c dc dt. The right side, the 4,000 squared, that just zeroes out when we take the derivative, and the r squared becomes 2r dr dt. I need to solve that for dc dt. So what I've done is I've divided both sides by 2c and let the 2's reduce. So I've got r dr dt over c, or divided by c. We know r at the instant when the height is 3,000, r is 3,000, so we can replace that. We know dr dt is 600 feet per second, we can replace that. And Tyler said that we can figure out C pretty easily, because at the instant that R is 3,000, we're basically looking at a 3-4-5 ratio. So C is 5,000. So when R is 3,000, C comes out being 5,000. If we don't notice the 3-4-5 ratio, we can go ahead and use Pythagoras, and it'll tell us the same thing. We make all those substitutions and do the multiplication and division, and we get 360 for dc dt. That's 360 what? Feet per second, yeah. So the distance from the television camera to the rocket is changing at a rate of 360 feet per second at the instant that the rocket is 3,000 feet off the pad, or in the air, or high. Questions on that part? Okay, let's go to question 2, or part B here. So I'm going to write the dc dt over here in case I need it, and I'm going to clear some space. And I'm keeping around the fact that when r is 3,000 feet, c is 5,000 feet. And I'll go after dr dt. Oh, d theta dt is what I'm after next. So if I'm going to find d theta dt, I need to use the variable theta. The only given rate I had was dr dt, so I need to use the variable r. So I have to use those two variables in some kind of relationship. And now I want to find an equation that uses those and possibly the 4,000 and or the c with it. So what relationship did you guys see that works fairly? Just do tangent. I didn't use an inverse tangent directly. I just used a tangent directly. I just said tangent of theta is equal to r over 4,000 and started with that. That's a function that relates theta and r, which are the thing I want to know about is theta. The thing I know about is r. So I've got those related in one equation, and I'm ready to go. Some of you guys, I know, tried different functions. I know some people were trying the Lob cosines function because it was similar to another problem we did. That runs into a lot of work. Let's take the derivative of this. What's the derivative of tangent? Secant squared. So we have to follow the chain on that. So because tangent theta is going to give us what? Secant squared theta, d theta dt. On the other side, I'm going to think of that as 1/4000th times r, just like 5r, and take the derivative. So what's going to happen with the dr on that derivative? It'll just be dr dt, and still times 1/4000th or divided by 4,000, however you choose to write that. I've chosen to go ahead and split that and think of it as a multiplier. So the derivative of tangent theta is secant squared theta times d theta dt. That's going to equal the derivative of the right side, which is just 1/4000th. That's a constant multiple, so it just comes along for the ride, times dr dt. I know dr dt, and I want to know d theta dt. I have to find some way to replace secant squared theta. Before I did that, I just divided it to the other side. Dividing by secant squared, or dividing by secant is the same as multiplying by its reciprocal, right? Dividing by something is the same as multiplying by reciprocal. What's the reciprocal of secant? Cosine, right. So what I've done is I've divided both sides by secant squared, which is the same as multiplying by cosine squared. If we look at this triangle, at the instant when r is 3,000, c is 5,000, I should be able to find the cosine of angle theta, because it's just adjacent over hypotenuse. So cosine of angle theta should be 4,000 over 5,000, or 4/5. So that's what this is talking about. When r is 3,000, cosine of theta, that whole piece there, expression, is just 4/5. So up here, cosine squared theta, I can replace the cosine theta part of that with 4/5. So that becomes 4/5 squared. 4/5 squared is 16/25 divided by 4,000 times 600 comes out to be approximately 0.096. What are the rates? Or what's the unit on that? This is an angle measure, but we're not working in degrees. Yeah, it's radians per second. Yeah.